Hello everyone. In this section, we will discuss how to build a neural network on TensorFlow by using XOR operation. So till now we have covered how to build a neural network in TensorFlow. Now we will discuss about how to build a neural network on TensorFlow by using XOR. So here is the table of content. First we will discuss how to build a neural network on TensorFlow for XOR, and we will also discuss about the truth table, and next we will discuss the implementation of XOR neural network. So before starting with XOR implementation in TensorFlow, let us see the XOR table values. And first we will discuss what is XOR. XOR is basically known as exclusive OR, which equates two binary number bitwise, that is 0 and 1. So it will check the condition. If both the bits are the same, the XOR operator output will be a 0. For example, if the first input value is 0 and the second input value is 0, then the output comes in the order of 0. So if both bits are different, the XOR operator output comes with 1. So basically the bitwise XOR sets the input bits to 1 if either but not both. So for example, if a person can flip the coin, then the face of the coin will be either tail or head. So the following given truth table, we come to know that the output of the gate is 1 only when one of the output is 1. As you can see that the first input value is 0 and the second input value is 1, then the output comes 1. So if both the inputs are identically, then the output is 0. Suppose we have take first input value 0, second input value 0, then the output comes 0. Now that we know how an XOR gate works, let us start with the implementation of XOR using TensorFlow. Now we will build simplest neural network with 3 neurons to solve the XOR problem and train it is using gradient descent. Now we will start with the implementation of XOR using TensorFlow. First we have imported all the required libraries. As you can see that we have used TensorFlow and the NumPy. And for creating the session, we have used tf.compat.v1.disable eager execution. So in the next step, we have created placeholders for input and output. As you can see that by using tf.compat.v1.placeholder, we can easily create the input and the output. So the input will be of the shape of 4, 2 and the output will be shape of 4, 1. Now after that we will create a training for input and output by using input underscore XOR underscore value. In this we have assigned the values in which we have already taken in the truth table. So after that we have set a standard learning rate, that is 0.01, and the number of epochs that the model should be trained for, that is 10,000. Now we will create a hidden layer for the model. The hidden layers have weights and bias, and the operation of the hidden layer is to multiply the input provided with the weights and then add bias to the product. So for this I have used the tf.variable, and within this I have used the truncated normal and assigned the shape, that is 2, 2 and name is weights. Same in the case of bias, I have set the 4, 2. Now after that we create an output layer for the model. The output layer, similar to the hidden layers, has weights and bias and does the same functionality, but instead of a ReLU activation we use the sigmoid function to get the outputs between 0 and 1. Now after that we create a loss and cost function, and this calculates the cost for the model to train on the given data. So here we do RMSE of the predicted output value and the actual output value will return. So here RMSE stands for root mean square error. We have to find in it. After that we create a training variable to train the model with the given cost loss function with an Adam optimizer. So in this we have provided the learning rate in order to minimize the loss. Now that all the required things are initialized, we will start a TensorFlow session and start training by initializing all the variables which we have declared previously. Now we will train the model and give out the prediction. So here we run the training on input and output. Since we are doing supervised learning, Then we calculate cost for every 1000 epochs, and in the end predict the output and test it against the actual output. So as you can see that we have printed for every 1000 epoch. Training is completed. So with this we have completed the TensorFlow XOR implementation.